Okay, so this is a video where we work out the 3 quantitative problems that are in the homework of Unit 4, Module 2. The remainder of the homework is review from Unit 3, Module 2 up to Unit 4, Module 1, and there are other videos covering those questions. All right, so let's start with what we're being asked. Well, it always begins with a chemical reaction. So we have calcium carbonate being heated. It decomposes into calcium oxide plus CO2. And now we want to balance it. So we put a 1 in the most complicated molecule, CaCO3. And now what we're going to do is we put a 1 in front of calcium oxide because we need a 1 on calcium. Put a 1 on CO2 because we need a 1 on carbon. And then we just count up the atoms: 1 calcium, 1 carbon, 3 oxygens, 1 calcium, 1 carbon, 1 oxygen, plus 2 oxygens. So 3 oxygens total, so this is balanced. All right, so now what we're going to do is start looking at the masses involved. So 1 mole of calcium carbonate is 40 grams from calcium, 12 grams from carbon, and 3 times 16 grams for oxygen, giving us 100 grams per mole. Calcium oxide, do the same thing, 56 grams per mole, and for CO2, it's 44 grams per mole. All right, so what is that? So we're given, so let's take a look at the kilogram. The kilogram is 1,000 grams. So let's take a look at some of the work here. So 100 grams of calcium carbonate makes 56 grams of calcium oxide, right? We get that from the chemical reaction. So 1,000 grams of calcium carbonate makes 560 grams of calcium oxide. And now 10,000 grams, which is 10 kilograms of calcium carbonate, makes 5,600 grams of calcium oxide, which, if we divide by 1,000, would give us 5.6 kilograms. So we could do this problem pretty straightforward. We don't really, once we know the masses, we can kind of take a look at, okay, so what we're really doing is just multiplying the masses by, by 100. Okay. Let's take a look at doing this problem using ratios and conversion factors. All right, so what we have is that for every 100 grams of calcium oxide, we make 56 grams of calcium carbonate. Right, so calcium carbonate, 100 grams of calcium carbonate makes 56 grams of calcium oxide. If we had 100 grams, we'd make 56. But we don't have 100 grams, we have 10,000 grams. So we want to find out what value here satisfies this equation. So if we solve for x, we get 5,600 grams, or 5.6 kilograms. Now, doing it the conversion factor method, so there's a formula. So let's go over the formula. Mass given times 1 over the molar mass of the given times the mole ratios of wanted value over given, right? These are moles, mole coefficients, times the molar mass of wanted, right? So first you divide by the molar mass given, then you multiply by the coefficients, and then you multiply by the molar mass of wanted. That's our formula. So now what we're going to do is just plug it in the formula. So 100 grams is the molar mass of calcium oxide. We know our reaction is 1 to 1 because it's calcium CO3. The 1 here makes calcium oxide 1 plus CO2 1. So these ones are coming from the chemical reaction. Put in our 56 grams for the molar mass wanted, starting with 10,000 grams. So if you plug that in, 10,000 divided by 100 times 56 times all these ones, you get the same answer. 5,600 grams, or 5.6 kilograms. And remember, we could divide here by 1 kilogram is 1,000 grams, and that's where we get the 5.6 2.6 kilograms. Okay, so two different ways to do it, and each one of the problems in this video, we'll do them each way. I would suggest trying both, find out which way works best for you. Okay, the next question is, how many moles of hydrogen gas can be produced, are needed to produce 90 grams of water? All right, so again, we always start with the balanced reaction. This is a combustion. So what we're going to do is balance water last. So we put a 1 in front of H2. That means there's 1 water. If we count up the number of oxygens, we only have 1 oxygen in the products. So we put a half in front of O2. Because we can't have fractions in our balanced chemical reactions, we multiply both sides by 2 to clear the fraction. And we get 2H2 plus O2 makes 2H2O. Right, so now we have our balanced reaction. What does this tell us? It tells us that we have 4 grams of hydrogen reacting with 32 grams of oxygen to make 36 grams of water. Right, so that's our chemical reaction in terms of mass. And so if we wanted, so sorry about that. But what we could do is we can, there we go, let's start here, is that we get from the balanced reaction that 36 grams of water are made from 4 grams of hydrogen, assuming that we have all the oxygen we need. And so we're given 90 grams of water, and now we want to solve for, okay, what is the X number of grams here that satisfies this ratio? Okay, so when we do that, solve for X. X is 10 grams of hydrogen. But since we were asked for moles, we know that every mole is 2 grams of H2, which gives us 5 moles. So 5 moles of H2 are required if you have all the oxygen you need to make 90 grams of water. Okay, let's take a look at using the coefficient way, Right, so we start with the formula, grams of wanted times 1 over the molar mass times the balanced reaction coefficients times the molar mass, right? So you kind of, now it's keep in mind here, this is given, so the grams of given, molar mass of given. Okay, so that's our formula. So we're going to plug in the values we have. So we're given 90 grams of water divided by the molar mass of water, which is 18 grams. We know the coefficients are 2 moles of H2 for 2 moles of water. And now we find the molar mass of H2, which is 2 grams of H2 per mole. And now we've set up the problem. So all the problems are set up this way. This is the formula, 1 over the molar mass given times the ratios times the molar mass wanted. Okay, so now we do that, and we get 10 grams of hydrogen. Now I keep calculating the mass, but although the problem just wanted you to find moles, so we really could have stopped at the second parenthesis. So we just start again. 1 over the molar mass, and then we just stop here. 2 moles of H2 for every 2 moles of water. If we do that, we get 5 moles of hydrogen. So doing this problem is fairly straightforward if you have a balanced reaction and you use this formula, 1 over the molar mass times the ratio of the coefficients in the reaction times the molar mass of what is asked for. And every time, if you are going to use the ratio method, it's a really good idea to just write the masses out above your chemical reaction. Keep in mind you must multiply the molar masses times their coefficients for it to work. So you don't put 2 grams of H2, you put the 2 times 2, right? The 2 times 2. That's important. All right, we have one more example. and it's the limiting reactant problem. All right, so this is the most complicated problem we have, so let's go over this. We're going to do it in two ways. We'll start with the conversion factor method, and then we will show how to do this problem using the ratio method. All right, so first, as always, doesn't matter what method you use, you have to have a balanced chemical reaction, and that starts with writing out all the reactants and products. All right, so what we're going to do is we're going to put a 1 in front of our complicated molecule, H2S. We're going to balance that first, balance O2 last. Okay, so we have to put a 1 in front of SO2 because we only have one sulfur and H2S. We have to put a 1 in front of H2O because we need 2 hydrogens on both sides. That leaves us now with only having to balance oxygen. We see we have 3 oxygens in the products. We need 3 oxygens in the reactants. So we put 3 halves there. So anytime you need an odd number of oxygens, you're always going to use this half notation and then multiply everything by 2. So it's really convenient. And now we have our balanced chemical reaction. Okay, and so we're going to put in the masses. These are the masses reacting, not the molar masses. It's the molar mass times the coefficient. So H2S is 34 grams per mole, but we're multiplying by 2 to get 68 because that's how much reacts. 96 grams, so 68 grams of H2S will react with 96 grams of O2 to make 128 grams of SO2 and 36 grams of water. All right, so let's take a look at the coefficient method. Which one is the limiting reactant? We know it's limiting reactant because we're given both masses. So anytime you're given 2 masses, you know it's limiting reactant. Okay, so 100 grams of given, right? So we start with H2S given, we divide by the molar mass of given, times the mole ratio of the wanted SO2 coefficient over the given coefficient. And both of these are 2 in the balanced reaction. Here, here, and here. And now we multiply by the molar mass of SO2. And the molar mass of SO2 is 64. All right, so we do this calculation and we get 188 grams of SO2. Now, if this is limiting, then when we try to do this with oxygen, we will make more. If this is not limiting, then oxygen is going to make less, and this one would be more. So let's check. All right, so same thing, divide by the molar mass of oxygen, multiply by your coefficients, 2 moles, now it's 3 moles of O2. Multiply, it's still 64 grams, it's still the molar mass of SO2, and we get 133 grams of SO2. So this is the smallest amount. That means O2 is limiting. It means H2S is in excess because it makes too much or more than O2 does. And so we've now determined that the limiting reactant is oxygen, and the maximum SO2 we can make is 133.3 grams. So remember, using the formula this way helps you organize the calculation once the reaction is balanced. All right, let's take a look at the ratio method. So the first thing we do is with our balanced chemical reaction, we just write in our masses, which is the molar mass times our coefficient. So H2S is 34 grams per mole times 2 is 68. O2 is 32 grams per mole, but times 3 is 96. SO2 is 64 grams per mole times 2 is 128. And, we don't need water, but water would be 2 times 18, or 36 grams of water. Okay. All right, so what we do is the first thing we say is that we have 68 grams of H2S will make 128 grams of SO2. We don't have 68 grams, we have 100 grams of H2S. How many grams do we make? All right, so we solve for X here, and it's 188 grams of SO2. Do the same thing for oxygen, so 96 grams of oxygen makes 128 grams of oxygen, right? That's from our chemical reaction. but we don't have 100 grams. We have 96 grams. We're just a little bit more, so we expect the answer to be very close to 128. We look at it, we call it Y. Solve for Y grams, and it's 133 grams of SO2. So we now identified oxygen as the limiting reactant, and the maximum mass we can make is 133 grams. Okay, so these are all the calculations you're responsible for in our reaction. And so this is using the mass method. You also want to keep in mind that if you do have this problem, you are also going to be asked for molecules and particles. So let's make sure that that's clear. So what does that mean? That means, like you say, if I have 50 particles of H2S, how many water, let's say, do I make? Right? So you could use the same method. It's going to be 1 mole, so 50 H2S. So there are 2 waters for every 2 H2S, and then we get 50. So 50 waters are made from 50 H2S. Right, so you can do this kind of analysis with particles, or you can do it with mass. Right, I hope this helps with the homework. These are the 3 types of problems you need to be able to do on the test exam 4B.